Hi guys, welcome back. In the last lecture, we have learned how to securely store users' password using Bcrypt. We have also implemented the API to create a new user for our simple bank. Although I didn't show you how to write unit tests for this API, since it would be very similar to what we have done in lecture 13 of the course. With the help of gomock, any API unit test can be written with ease. However, if you have tried to write unit tests for the create user API yourself, you might find it a little bit tricky due to the fact that the input password param is hashed before storing in the database. To understand why, let's look at the simple version of the test that I've already written here. Basically, we first create a random user to be created. Then we declare a table of test cases where we can define the input request body and two functions to build store stubs and check the response of the API. There are several different cases we can test, such as the successful case, internal server error case, duplicate username case, invalid username, email, or password case. We iterate through all these cases and run a separate subtest for each of them. In each subtest, we create a new gomock controller and use it to build a new mockdb store. Then we call the build stubs function of the test case to set up the stubs for that store. After that, we create a new server using the mock store and create a new HTTP response recorder to record the result of the API call. Next, we marshal the input request body to JSON and make a new post request to the create user API endpoint with that JSON data. We call server.router.serve HTTP function with the recorder and request object. And finally, just call tc.checkResponse function to check the result. It's pretty simple, just like what we've learned in lecture 13. I highly recommend you to watch it first to make sure you fully understand the code before continue. Now, for today's lecture, we only need to focus on one case, the successful one. As you can see here, the request body's parameters are all valid. In the build stub function, we expect the create user function of the store to be called with two parameters. In this simple version, we are using gomock.anyMatcher for both of them. Note that the first argument of the store.createUser function is a context, which we don't care about its value, so it makes sense to use anyMatcher. However, using that same matcher for the second argument will weaken the test, because it won't be able to detect if the createUser params object passed in the user function is correct or not. I'm going to show you how in a moment. For now, let's just skip this gomock.anyMatcher. And this create user function is expected to be called exactly once, and it will return the user object with no errors, since this is a happy case. For the check response function, we just check the HTTP status code to be 200 OK, and make sure that the response body matches the created user object. That's it. Let's run the test. All passed. So we're good, right? Well, not really. As I said before, this gomock.anyMatcher will make the test weaker. How? Let's see what will happen if in this createUser handler, I set the argument variable to an empty createUser param object. This will discard all input parameters of the request and will create a completely empty user in the database. So it should not be allowed, and we expect the test to fail. However, if we run the test again, it still passed. This is very bad, because the implementation of the handler is completely wrong, but the test could not detect it. Another case that the test would not be able to detect is like this. Let's remove this setEmptyArgument statement, but it will ignore the user's input password and just hash a constant value, such as XYZ here. Then go back to the test and run it again. As you can see, it still passed. This is unacceptable. The test we wrote is too weak. We need to fix it. One thing that might come to your mind is, what if instead of using gomock.anyMatcher, we use something else such as gomock.equalMatcher? Let's try it. First, I will declare a new argument variable of type db.createUserParams, where username is user.username. For the hash password field, we need to hash the input naked password. So let's go up to the top of the test. Here, after generating the random user object, we call util.hashPassword and pass in the generated password value. This function will return a hash password value and an error. So we have to make sure error is nil using require.noError. Then now we can use a hash password value for this field. Next, the full name should be user.fullname. And finally, email should be user.email. With this object, we can now replace gomock.anyMatcher with gomock.equal argument. Okay, now let's try to test a case where all input parameters are discarded. Since we have used a stronger equal matcher here, the test should fail, right? Let's run it to confirm. Yes, that's right. The test failed as expected. The logs tell us it failed because of the missing calls, which is true, because although the createUser function was called, it was not called with the correct input arguments as we wanted. So is that it? Did we fix the issue? Unfortunately, no. Let's see what will happen if I remove this line. Now the createUser handler function is correctly taken into account all input parameters, so we expect the test to pass. Let's run it to confirm. Sadly, the test didn't pass. It still failed due to missing call. And the real reason is because the createUser function is called with an input argument that doesn't match with the one we expect. Here in the log, we can see clearly what value the mock store got compared to what it wants to receive. It looks like the username, full name, and email are all matched. Only the hash password values are different. Do you know why? Well, if you still remember what we learned in the last lecture about bcrypt, it uses random sort when hashing the password to prevent rainbow table attack. So even if we pass the same password value into the hash function, it will always produce a new hash value every time. Because of this, the hash value that we created in the test and the one in the createUser handler will always be different. So we cannot simply use the built-in gomock.equalMatcher to compare the argument. The only way to fix this properly is to implement a new custom matcher on our own in this case. Although it sounds a bit annoying, it's actually very easy to implement. And I think it will be useful for you if you ever encounter some special cases like this in your real project. Okay, let's learn how to do it. First, I will remove this hash password because it is not needed in the custom matcher that we are going to implement. We will have to replace this gomock.equalMatcher with our own matcher. So let's open its implementation. It's simply a function that takes the expected argument x as input and returns a matcher interface. In this specific case, it returns an implementation of the matcher that matches on equality. For our custom matcher, we will have to write a similar implementation of the matcher interface, which has only two methods. The first one is matches, which should return whether the input x is a match or not. And the second one is string, which just describes what the matcher matches for logging purpose. If we scroll down a bit, we will see several built-in implementations of the matcher interface. This one is anyMatcher, which will always return true, regardless of the input argument. Then this is the equal matcher that we are using. It uses reflect.deepEqual to compare the actual input argument with the expected one. The custom matcher that we're going to implement will be very similar to this one. So I'm going to copy all these functions and paste them to the top of the user test.go file. Then let's change the name of this struct to equal createUserParams_matcher. In order to compare the input arguments correctly, we will need to store two fields in this struct. First, the argument field of type db.createUserParams. And second, the password field to store the naked password value. Okay, now let's implement the matches function. Since the input parameter x is an interface, we should convert it to db.createUserParams object. If the conversion is not okay, then we just return false. Otherwise, we will check if the hash password matches with the expected password or not by calling ut.checkPassword function with e.password and argument.hashPassword. If this function returns an error, then we return false. Else, we will set the hash password field of the expected argument to the same value with the input argument.hashPassword. And we use reflect.deepEqual to compare the expected argument with the input argument. That's all. Pretty simple, right? Okay, Now let's update this message of the string function to include the expected argument and naked password values. And our custom matcher is done. Next, we will add a function to return an instance of this matcher, just like this equal function that returns an equal matcher instance. I'm going to change this function's name to equal createUserParams, and it will have two input arguments, a db.createUserParams object and a naked password string. This function will return a matcher interface, which in our case is a equal createUserParams matcher object with the input argument and password. There's a syntax error here because the matcher type belongs to the gomock package, so we have to update it to gomock.matcher. Alright, so now we have everything we need for the new custom matcher. Let's use it in the unit test to see how it goes. I'm going to change this gomock.equal to equal createUserParams, then pass in the createUserParams argument and naked password. Just like that, and we're done. Let's rerun the test. It passed. Excellent. Now let's try the case where we set this argument to an empty db.createUserParams object. We expect the test to fail. And it does fail, since the input argument doesn't match the expected one. Okay, how about the case where we ignore the input password parameter and just hash this constant password value, xyz. Let's rerun the test. It failed, just like what we expected. Only when we correct all bad changes we made so far, then the unit test will pass. So now our unit test has become much stronger than it was before, thanks to the new custom matcher that we've just implemented. And that's it for today's lecture. I hope you find it interesting and useful. Thanks for watching and see you in the next one.